Hello, everyone. Good morning. How are you all doing? Good, good. Perfect, perfect. So, all set. We are here to study pandas and numpy, right? I'm doing good too. Thank you. Pandas, numpy, visualizations. Are you ready to get in? All right, all right. Anyone who's taken a class with me before? Yeah, it's going to be numpy, but the whole module, you're going to be with me for the whole module. No? Okay. All right. So, quick introduction about me. As the name suggests, I'm Rishabh Sukhija. Who will you be the instructor now onwards? Yeah, I'm the instructor for this module, NumPy, Pandas, and visualization. Perfect. So, quick introduction about me. I am Rishabh Sukhija, and I have close to 10 years of experience. And I currently work as a principal data scientist. It's one of the leading firms, and I have worked with product-based companies, startups, and consultancies, service-based companies. And I have worked with clients all across the globe. So name a continent or country, there's a high chance that I worked a client from that place. And yes, I have dealt with multitude of business problems related to machine learning, deep learning, and these days even generative AI. So I think I'm in a good state to take your sessions going forward, and that's me. Okay. So, since I come from the industry and all of my experience is into data science, so we'll be taking this in a very, very, practical manner. I'll try to impart as much as knowledge from my own experience into these sessions, along with the, curriculum that you have. So that's it. And there are only two rules in my sessions, okay, which I really want you guys to follow. First rule is please do not shy away from asking any questions, okay? Please do not ask sorry please do not shy away from asking any sort of question, okay? uh, in my sessions there are no silly questions, there could only be silly explanations. So the onus is on me, not on you, okay? To get the maximum of these sessions, please be interactive and ask the questions. If something's not clear, please ask me to repeat. I might come up with a different explanation that might resonate with you, okay? That's one. And the second is please, please, please follow the first rule. Okay. That's it. That's it. Okay. Cool. So are we good? Should we get started then? Perfect. All right. Okay. And also just housekeeping things. Guys, this is going to be the Google Drive. Please pin it, save it somewhere. So I'll be uploading all the notes that you see, okay, in this Google Sheets, oh sorry, Google Drive, okay. Oh, thank you so much, Shubhadeep, looking forward. Okay, please save this, and we will try to do hands-on plus theory, because in my opinion, NumPy, Pandas, and when I talk about visualizations, it's Matplotlib, okay, and Seaborn. So we'll do it first. We'll understand some theory around it, and we are going to look at it from the practical sense. Okay, cool. Moving ahead, I'll cut off the video. I'll cut off the video because there might be some issue on the bandwidth when I'm sharing my screen. This is something that I have faced yesterday. So just cutting off the video. Okay. Cool. Um, all right. Mhm. And another trick that I use, guys, just to make sure all the logistics are clear, are fine. Okay, because what happens is that today, though, we had a introduction. I spoke about myself, so I know that you guys can hear me. But going forward, I will type in this OTP, and now if you can see my screen, can you type in this OTP in the chat box? If the font is good and you can see the screen, please type in this OTP. Perfect. So this OTP going forward is going to be for different classes, different OTP. So that's a very nifty trick that I use to make sure all the logistics are fine. If you can hear me, you'll be able to respond correctly. And if you can see it, you'll follow the instruction and type in the OTP. Perfect. This confirms that you can see my screen. Um, I did notice question somewhere. And also I might, at my end, when you guys send the chat, at my end it falls like a waterfall. So I might miss a few questions. So don't worry, please type it again. Okay. If I forget something to answer, or if I miss, okay. Can you just give an idea after studying these library, will we be job ready? Well, for the Python, in terms of the data science, if you practice well after our sessions, I think you can start at least preparing for these Python level roles. You would still need understanding around, inferential statistics and machine learning module. Then I think you'll be in a much better place, because that's what people are asking. And even I go and take interviews, so I know this is going to help you. This module is going to help you answer, 4 or 5 questions in the interview around Python for data science, but not the entire interview yet. What you told about the Google Drive. So the Google Drive, I'll be uploading all the notes there. Okay. So all I want is all your 100% attention. I'll be preparing the notes for you. Whatever you see on the screen will be shared. Yeah, of course you can. You can. We'll cross that bridge once we're there. Okay. Let's just get into it. I'll tell you how to follow in terms of the hands-on. Okay. Cool. All right. So you might have questions that, you know, why are we studying NumPy? Okay. Why are we studying NumPy? Will you cover a real-time project for portfolio? Well, that's not part of this module. I think there's going to be someone else as well who's going to do those hands-on sessions. But just for me, like my teaching method is that along with theory, I like to do, the hands-on because it serves well. At least for the learners, it's much more beneficial. Okay. So no, I'm not going to do any real time. But if we have time towards the end, we can have discussions about some ideas that you can, take on. Cool. Coming to the session. Okay, let's talk about NumPy. So NumPy, guys, how did NumPy even came into picture? Okay, initially, what happened was when Python was being developed, it wasn't being used for uh, data science per se. Okay. Even when I started my journey in data science like 10 years back, Python was not prevalent at all. It was there in bits and bits, but it wasn't prevalent. So we used to use some, language called R language, language R, and also SAS. But these days, as you might know, those kind of, languages are becoming kind of obsolete, and Python is the king. So NumPy is a really, kind of a backbone why things have really progressed in the favor of Python. That's why, wherever you go, Python is the requirement that they're looking in data analysts, in data scientists, and machine learning engineers. Okay, so let's study about a bit of history. So there was a library or a package called Numeric, and this was in 1990s in Python. Okay, in 1990s there was this package in Python called Numeric that was developed, and it kind of started the foundation. How it gave it gave the capability it gave capability to deal with numbers, to deal with numbers in Python. Okay, prior to this, Python was being used for some other things, software development and all those things, back end, front end. It was a very, very different kind of, uh, place where Python was. But in 1990s, this package was developed called Numeric, which changed the things. It gave the capability to Python to deal with numbers. Then came this very famous personality, Travis, in in 2000s. In 2000s, okay. What he did was he combined numeric library, numeric library with the concepts of numerical arrays. He combined this library of Python with a concept of numerical arrays. Okay. And that thing in 2000s came known to be as NumPy that we know today. That's how NumPy was, introduced to the world and started changing how Python is looked at for data science. Okay. Now, people did not stop here. People did not stop here. Array, you don't know what is an array? One, two, three, four. This is an array, right? Don't worry. If you don't know it, just stay with me. We are going to cover everything. Okay. But I'm guessing you're coming from Python classes already. You've covered your Python module, right? Oops, basic oops. And so I think you should be aware of arrays. Okay. Cool. If not, I would highly encourage you to, cover those classes as well. Because as the time progresses, things are going to become really hectic and the backlog will keep on piling. Okay, cool. So after NumPy was developed, guys, people did not stop there only. People did not stop there. They started looking into and developing other packages like pandas. Okay, pandas. Then they also developed SciPy for scientific things. Okay, then they also developed Matplotlib. They also developed Matplotlib. They also developed something that just changed the game, which is called scikit-learn. Scikit-learn, and popularly called as sklearn. Sklearn is where all your machine learning algorithms have been coded and kept for you to leverage. This you're going to look at in your machine learning module, this scikit-learn library. Okay. Then came TensorFlow. All these are made on top of NumPy. NumPy is the backbone, and TensorFlow are the things that you use for your deep learning, neural networks. Okay. So this is how things came into picture. After the development of NumPy, there was no looking back for Python. Okay. Now, in these sessions, in this module, we are going to cover NumPy, we are going to cover Pandas, we are going to cover Matplotlib, we are also going to cover Seaborn, which is an extension of Matplotlib specifically for visualizations. Okay, specifically for visualizations. Perfect. All right. With this history out of the way, okay, let's start looking into NumPy, what it is. Okay, what it is. Everything that I'm teaching is important. Okay, just pay attention. Let's start with the main content for NumPy. Now, NumPy, it is used to create arrays. It is used to create arrays. The arrays could be one-dimensional, two-dimensional, or multi-dimensional. Okay, and what we are going to look at, we are going to see how do you create these arrays, NumPy arrays. Okay, and we are also going to look at popular some popular functions in NumPy in this module. Okay, these popular functions are the ones that, in my opinion, based off my 10 years of experience in data science, I feel you'll be using this day in day out. So we'll be covering whatever is there in the curriculum, but from my side, I will also cover some additional functions and additional methods so that we are well prepared for the practical usage of these things in the industry. Okay, and we will also do hands-on to solidify our concepts, okay, in the classes itself. Then we will also be looking at Pandas, I think from the third session onwards. So NumPy is going to take between 2 to 3 sessions. Okay, NumPy alone is going to take 2 to 3 sessions. In Pandas, what Pandas is used for? Pandas is majorly used for dealing with data frames, dealing with data, okay, in a much more easy manner. Okay, so we are going to look at Pandas with the perspective of dealing with data frames. Data frame is a kind of a data structure, how you save the data. We are going to look at how do you store the data, how do you read the data, okay, and in sense like playing around with the data, meaning once you get the data, how you look at different things in the data, okay, as a data scientist or a machine learning engineer, or in fact even as a data analyst. Again, here we are going to cover popular functions. Since we cannot cover all the functions, like there are close to thousands and lakhs of functions in this Pandas and NumPy alone. So since we'll not be able to cover all of them, and also in my opinion, not all of them are also required, and you'll not be using all of them in your practical, industry also. So we'll cover those with the focus of what you're going to use in the industry. Okay. And again, as I mentioned for the NumPy, I'll also try to cover the hands-on to solidify our concepts. Again, it's going to take us 2 to 3 sessions on pandas also. Okay. Then after these, sessions, we are then going to move into Matplotlib plus Seaborn. These are two packages or libraries again. These we will be looking at because they are used for creating visualizations. So once you do all your analysis and everything, you need to visualize the data also, right? And you also have to explain what you've done. So these two libraries are going to be used for that. Okay. Okay. These two libraries are going to be used for that. Sir, will you change your typing text to normal? Cursive. It is cursive as in cursive is easy to write, right? You want me to write in capitals? Okay. Then basically, no licenses required. Okay. Here we are going to look at different different types of charts that you can develop or visuals that you can develop using these two libraries. Okay. And again, we are going to cover hands-on here. So Matplotlib and Seaborn, they are used for creating visualizations because once you complete your analysis and everything in industry, we typically go and present this to your boss, to businesses, to clients. So since these people that you're going to present to their non-tech people, and also for you on the way to get more understanding about the data, to look at the patterns, visualizations are really important. So for with that perspective, Matplotlib and Seaborn is going to be used. Okay. And I'm going to give you all the charts. Basically, you need to have this in your arsenal as a data scientist or machine learning engineer, that okay, these are the charts that I can create. So depending on the use case, you'll be able to create it. Okay, perfect. Here we are going to look at this in 1 to 2 sessions. Okay, cool. So that is going to be the content of all this module. Okay, these are the things that we're going to cover, and this is the plan. Any doubts, guys, in the plan? Are you with me? No, dashboard is part of Power BI or Tableau. But whatever in dashboard, you ultimately create your visuals, right? Different types of charts. So I'm going to cover how do you make these charts in the coding using Python. Okay, using Python. How do you understand? Yes, pie charts, area charts, all those things. Web scraping is not part of this module. Will not be covering it. So we can represent data in Python or anything else. Yes, you can. And also while you're dealing, right, even for you to understand what is happening with the data, because data is not going to be 4 or 5 lines, 5 rows. It's going to be thousands of rows, lakhs of rows, crores of rows. So it is not going to be easy to look at the data with eyes one by one. You will also need these visualizations for your analysis. Okay. Cool. Okay. I have attended every class. Arrays and multidimensional arrays were not discussed. But you know how it was used, right? Indexing, indexing of things. Okay. Cool. That's it. That's it. What you want. That's the only thing that you want. Okay. Cool. I will pick it up from there. I will indexing, slicing. Yes. Of course. Why not? Why not? Shubhadeep. Uh, yes, it is, Shrikant. It is. List is what is arrays in Python. Yeah. Cool. All right. Please explain the difference between Matplotlib and Seaborn. So we'll cover it once we have dedicated 1 and 2, sessions for it. So we'll cover it there. Today, NumPy. Okay, everything related to NumPy. Okay, cool. All right. Yes, you are, Shubhadeep. Let's get ahead into the discussion then. Now, picking up from where you have left, picking up from where you have left in the last session, in the last module. So in Python module, you understood something like list, right? As you mentioned, list. We were storing numbers like this, or even, we could store this there, right? This is what you had looked at. Then you might be asking a question that if we already have list, Python list, why do we need NumPy? Why do we need NumPy arrays? It is already leading to confusion. Why? Why do we need it? The short and sweet answer to this is because because NumPy is lightning fast. It is lightning fast, and because of its speed benefits, we use NumPy for data science work. We use NumPy for data science work. I'll give you an example. I'll give you an example. So this is an image, right? This is an image. The image is of 5. You can all see this is 5, right? Digit 5. Yes. Okay. Seems like more of an S. Okay. Good. But it is 5. Now, if you know, each and every image is made up of pixels. Each and every image is made up of pixel, right? So this, if I zoom in, look at this. This is nothing but a matrix of pixels. This is a pixel. This is pixel. This is pixel. This is pixel. All of them are pixels, right? And if you look at this, where you have the whitest spot, you have the highest value there. And where it is gray, it is little less. And where it is absolutely black, it is in negatives. So if I zoom out of this, now this looks like a 5. But internally, it is having these pixels. It is having these pixels, float values. Yeah. So ultimately, in machine learning, this data is saved as is saved as NumPy arrays. Internally, when you're dealing with this, you save this as a multi-dimensional array in data science, you with the help of NumPy. Imagine a task. Imagine a task. While I was here, let me discuss it from here. Imagine a task. This is one of the most popular, you know, projects that people do to identify whether the digit is what it is showing in the image. So here they are predicting whether the label is 5, the image is of 5. Label means their prediction. This means their prediction is 0 and the image is of 0. All like this. This is digit recognition. This is digit recognition. And these are handwritten. These are handwritten. Look at this 5. Look at this 5 and look at this 5. They're all different. This one and this one. This 2 and this 2. Everyone has a different set of, writing. This 6 and this 6. So to solve this, if we go with Python list, it is going to take us a lot of time. You need to do this at scale and at a lightning fast speed, which is where NumPy comes into picture. Which is where NumPy comes into picture. And this is just an example, guys. This is just an example that I felt that you will understand this much better. But internally, when you go and look into machine learning, deep learning, internally also under the hood of Python, without you knowing it, it is also using NumPy for doing these faster calculations. They need to process this entire data and say that, okay, and learn the patterns and then predict. And this is only one row. Like this, if you have thousands of images, you're going to have thousands of rows, for example. So understand the scale. If we go and use this list, it is going to be very, very slow. Have you used what do you say, Facebook or Instagram? Over there you get those images, right? You use images there. What is an image? I already told you. Images, nothing but pixels. So would you like that if you like a image on Instagram or on Facebook, should it take a lot of time to load? No, right? It will be a really bad experience. It will be a really bad experience. You want to render it as quickly as you want. And also, if you try to edit a particular image, typically what I do is I take a screenshot of something that I've done important on my phone. Then I try to edit it with the like this. I try to circle what is important. I try to crop things on the images. Those things, if you want to do really quickly, as of now, they happen instantaneously, right? If we went with Python list, it's going to take a lot of time. That's why NumPy came into picture specifically for NumPy data science. Okay. Now, with that motivation, if you understand why NumPy is used, so let me just write this also formally. NumPy is used for data manipulation. I just gave you examples from real world. Okay. But you as data scientists, since you're one level down than the end users, you're interacting with the coding and you are the data scientists and machine learning engineers of the future. You need to know NumPy really well. And how you are going to use NumPy is You are going to use NumPy for sorting the data. Once you get the data, you're going to use it for sorting. You can use it for handling missing values, right? Incorrect data. If you get incorrect data, you can manipulate it, right? You can also get rid of unnecessary information that is being passed, noise, right? There could also be mismatch of units, like something is in liters, but you want it in milliliters. Mismatch of units. All these things you can easily rectify using NumPy. Easily you'll be able to rectify and handle all these situations. These are only limited ones. There are many others cases, many others. We are going to look at it one by one in hands-on. Okay. Now you might be asking, okay, we understand NumPy is fast, and that is why it is used. But how is it fast? How is it fast? I'm not going to take your word for it. That you say that it is fast, and I will say, okay. Sir told me that it is fast, so I will say it is fast. You need to explain why. Why? Okay. So how is NumPy fast? Let's look at this. It is used in wide variety of things. In machine learning and statistics, NumPy is used in variety of things. As I said here, as I said here, it is the backbone of all these other packages. It is the backbone. Okay. So these are some of the things that I just spoke with you so that you will understand this much better. Internally, I also said that under the hood, without even you knowing, NumPy is somewhere being used. Even when you're building a model, you're doing some inferential statistics, something. Okay. Cool. Now, how is it fast? First reason is that NumPy is developed is, dev- is developed on top of C language. Okay. And what is a C language? C language is a compiler type language, right? Not interpreted language. Python, what is Python? From your Python module, what type of language is Python? Interpreter, right? Whereas Python is interpreted. So that is one of the reasons why NumPy inherently is fast, because it is developed in C, not in Python. Okay. Then second, NumPy arrays are are homogeneous. Are homogeneous. What do I mean by homogeneous? What do I mean by homogeneous? There is only going to be one type of data inside the array. Whereas in list, you could save anything, right? You could save float also, you could save integer also, string also in the same list, same Python list, right? In NumPy arrays, however, you'll be able to save only one type at a time. Okay, we'll look at this. And also there is something that gives a bit more of speed advantage to NumPy is that it does element wise operations. Element wise operations. I'm going to touch upon this with a practical example once we go to the hands on. Okay. But for now, just understand that each element is operated on. Each element is operated on in NumPy. Okay. Cool. Okay. All the muting and unmuting is towards the end. Okay. In my past experience of taking more than 2000 hours of teaching, I have realized that, there are two set of questions that people have. One is curious type of questions. The other is something that is relevant to the content. So if you type in your question, I'll be able to answer it now if it is really relevant to the context that we're discussing here. If it is more of a curious type of question, like what if I do this, what if I do that, that is kind of thing, please type in the question here, Feroz. Then uh, I will answer all that towards the end. Okay. I will answer all that towards the end. All the curious type of questions. All your questions will be answered. And also, in my experience, what I've seen is if you just let me speak for another 5-10 minutes, most of your questions are going to be answered already. Okay. Cool. Let me take some more questions. Mixed, highly interpreter. Okay. This was that you guys were responding. Not index wise. No, it is not. I really don't understand what do you mean by index wise. Probably you mean element wise only, Shubhadeep, but we'll look at it. Okay. How it is integrated Python with C language. Okay. Srinivasa, what happens is at the bottom, it is C language that is working, but there is a wrapper on top of it which helps to integrate it with Python. So all the memory level things are happening in C when you're interacting with your memory. How it is coded and everything is C, but there have been, some things or some handshakes done with the Python using any sorting according to data type or element wise. We'll look at it. We'll look at it. We'll look at it. If C is not so fast in arrays, and you said that we are doing operation by element wise, then it should be too slow. How come it is so fast? Huh? I'm coming there. Why it is fast? I'm just going to explain that. So that is typically the great example of why I'm saying that just wait for 5-10 minutes, all your questions will be answered. Okay. And C is fast. C is fast. I'm not saying C is not fast. C is much faster than Python. Okay. So one level of gap was there that I have covered. Now, the third point. Third point. Let's look at this in detail. Let us go one step down and understand this. How Python lists work, how Python list will work. Okay. Compared to compared to how NumPy compared to how NumPy arrays will work. Arrays work. Okay. How did we define in Python list as like this, right? 1, 2, 3, 4, 5. Right? That is how we defined a Python list, right? Okay. Okay. And how do we define it in NumPy? it is, let's say B, you will say NP. NP is for NumPy. Okay. Array, NumPy array. And in round brackets, you will put 1, 2, 3, 4, and this. That is how you define a NumPy array. That is how you define a NumPy array. Okay. One difference. Second is once as soon as you write this line in Python, okay, as soon as, yes, you need to import the library. I'm going to show this in hands-on. Just pay all your attention here. This is kind of important. Once you write this line in Python, what is internally happening? What is internally happening is this. A memory block is being associated with this, right? A memory block is associated with it. And how is that memory block? How does that memory block look like? It looks something like this. In your hard disk, memory block is like this, okay, in the red. So you have all these memory blocks, okay. There is some address associated with each memory block. Like this, you have these memory blocks, okay. And each one of them will have an address. Let's say 01, B23, something, something, 01B24, and so on. Okay. 0C481, 0C482, and so on. Okay. This is the address, memory address of that block. Now, what happens is as soon as you define this, okay, one, let's say you have one here, this one and two and three, four and five, they are not saved sequentially. Okay. Meaning, first point is that it is not saving in continuous memory blocks. Meaning, this one will be somewhere here, then two will be here, three will be somewhere here, four will be somewhere here, five will be somewhere here. It is in a haphazard manner. Continuous memory blocks are not used. And in fact, these things, this one is not at all stored here. In fact, one is not at all stored here. You know what is stored here? This address is stored here. That this address is stored here. Again, this address for two is stored here. This address. This address is stored here. It is pointing to that memory location. It is pointing to the memory location. It is not storing the actual number there. So what happens is that once you want to do some, extraction, let's say I want to access element number 3, what it will do is internally, it will go to this, address. It will find that, okay, this is the address. Then it will go to the memory and it will say that, okay, I have reached this address. Then it will pick this element at that address and then it will print it to you. If you're just trying to print it, those many operations are happening internally. Okay. Okay. How is this different from NumPy arrays? How is this different from NumPy arrays? Okay, I'll repeat once. As soon as Python lists are defined like this, A is equal to 1, 2, 3, 4, 5. Okay. What happens is a memory block somewhere at all you're saving in your computer or laptop, right? This one is being saved somewhere in the memory block. That memory block is being denoted by this red stack that I have developed. Okay. Imagine this is the memory. It has different partitions. Now what happens is first element here, you don't have one number here. You have this address here. It stores this address OB01B24. So whenever you write something like print A and the first element, what happens is it says that, okay, I need to go to the first address in this list. It comes here and sees that, okay, in the first element, 0th index, I have this address. So it goes to this address. From that address, it says that, okay, this is the element that is present here. It will go and bring that element and then it will show 1. That is how it works internally. Okay. It is not saving it in a continuous block. So if I want to access something that is kept here, I need to go and refer to its address first. Okay. But in NumPy, things are saved continuously, saved in continuous blocks of memory. It is saved in a continuous block of memory. So what you need to do is you need not every time go and look for a new address. What you can do there is you already have the first address. Or let me show you in this manner. If I take this from here, copy, paste. In NumPy arrays, what happens is it will save it in a continuous manner. Like this is 1, 2, 3, 4, 5. That is how it is going to save. So if you have this address OB1 23, okay, if this is the address, when you say that print B 0th index, what it will do is it has stored already this address. It will go and pick this element and print. But if you want to print the some element that is kept on third element, let's say you want to print 3, what it's going to do is it is not going to go and fetch the address. It has already points to this address, that is the starting address. Then it will add 2 blocks to it and it will already reach here without actually going to the memory location. It will auto calculate because it's just a summation. It says that this element is 2 steps away. This element is 2 steps away from this address. It will quickly go calculate the address and directly pick it up from there. It doesn't have to look in the memory, search in the memory. Okay, where is this address? An analogy would be if a postman, think it in this way. This is a bit more technical. Okay. If this is a bit more technical from people coming from non-tech background, understand this analogy. If a postman is bringing a letter, okay, each and every letter in the city is having address. So to deliver five letters or couriers, they have to go look at the address and then search where is that house, go and deliver it there. Right, right. Everyone with me? It will take them a lot of time to go find this area in the city, find the house, and then deliver it there. Then go to some other area, find the house, and then deliver the second courier, third courier, find the fourth area, go and deliver the courier there. It is going to take a lot of time. But what if, what if the postmen they receive those five couriers from five neighbors. They are in one apartment building. And they are staying at the same floor. Let's say they are staying on the second floor, and there are five houses on the second floor: 201, 202, 203, 204, 205. What they need to do? They need to just look at the first address. Just look at the first address. That okay, this is 201. I have found the area. This is the building. Let me go to the second floor. Once I reach to the second floor, I will just deliver my courier one by one by one by one. I don't have to look for another area at all because everything is just there. All the couriers have to be delivered on the same floor. Which one is going to be fast? Getting my point? Do you agree? Is the understanding better now with the analogy? That is exactly what is happening here. That is exactly the difference between Python list and NumPy arrays. Okay. Okay. Cool. 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 Other thing, the second point, why it is faster. Things don't stop there. Things just don't stop there. That okay, this is non-continuous in memory block. This is continuous in memory block. That is not only the difference. The other difference is the other difference is in Python list you can save. They are heterogeneous, right? They are heterogeneous, meaning you can define an array like this. This is one, this is string or character two, then this is float, and so on. Right? You can do this in list. This is my integer, this is my string, and this is my float point. Right? We can do this. We can do this. Basically, you can save different data types in a single list. What if, what if I do a operation like A0 plus A1? Does the addition work with strings? Does the addition work with string? But if you do this, if you do this, you will get this or an error. You will get an error. That plus is not associated with string, right? Or they will say that, okay, we cannot do this, or it will do something internally and will concatenate and give you this, right? Right. So what is happening? What is happening? What is happening? There is one more level of check that list have to do. List have to do when you give it an operation. What it is doing, just think it. It is saying that, okay, I need to pick the element kept on this address. It will go find that address, go to that element, and then it will check what is its data type. What is the data type? Okay, this is integer. Let me bring in. Then it will go and fetch this element. It will find the address first, go to the second element, bring in the element, and it will realize that the element has what data type? String. So it cannot perform this operation. There is one more level of check that they have to do. Isn't it slower? Isn't it slower? There's one more step involved, right? There is one more step involved. Can I or can I apply this operation or not? They need to check the data type also. Whereas this problem is not there with NumPy. Why? Why? Because they are homogeneous. Same data type. So if I say A0 plus A1, it will blindly go and add. It doesn't have to search for the second memory. It can calculate it. It can reach the second element. And it doesn't have to do that check whether I can apply this operation or not. It will blindly apply the operation. That is why the speed comes in. That is why the speed comes in. So this is going to be 1, 2, 3, either like this is or an integer array, integer, or you can also define, if you want a string array, you can get everything as string. Do it like this: 1, 2, 3, 4. This is a string array, but all of them are going to be same data type. Are you with me, guys, till here? Are you with me? Type a CLR if these 2 points are clear. Okay, good, good, good. Perfect. These are the reasons. These are the reasons why NumPy is fast. These are the reasons why NumPy is fast. Okay. C language, not Python. Then it stores homogeneous. It will do element wise operations. It will do element wise operations. Keep this in your mind. I'm going to touch on this a bit more when we go into hands on. And now, internally also, like a perfect computer engineer who deals with OS, operating systems, you have from the ground up understood how internally Python lists and NumPy arrays work. You have an in-depth knowledge of how it is working. Okay. Okay. Yes, don't worry. Everything is going to be shared. Whatever I'm writing, whatever you're seeing on the screen, it is going to be shared. That's why I told in the beginning of the class, I am making the notes for you guys. I want 100% attention from you on the board, on the screen. Okay, cool. All right. This is the theoretical part, guys. This is the theoretical part. And let's go for a quick break. Once we come back, I'm going to show a few more things in NumPy, but now with hands-on in Python. Okay, so that you get the flavor of how things are shaping up in NumPy. Okay, cool. Let's go for a quick break. What about AI if we mix NumPy with AI? Pranav, What is AI? What is AI? See, machine runs on algorithms. No, it is not that, Shubhadeep. You're teaching a machine to learn. You're teaching a machine to learn. Artificial intelligence is imparting an intelligence which is human like to machine. That is why it is artificial intelligence. The learning capability of the machine is machine learning. So, what AI is doing is these are algorithms in AI: linear regression, logistic regression, deep learning, neural networks, gradient descent. All these things are algorithms of AI and machine learning. These algorithms have been coded, right? These logical steps have been coded. They've been coded somewhere, and they have been coded to use data, right? Internally, what is happening is when they're learning, when they're applying these steps, when they're applying these steps that, okay, I need to do this step one, then step two, then step three. Within those step one, step two, step three, data is being manipulated. Data is being manipulated. And how is data being manipulated? How data is being manipulated? Using NumPy. Exactly. Exactly. So this statement of yours, Pranav, that if we mix NumPy with AI, you're not mixing anything. They are already NumPy. AI is built on top of NumPy. At least that is how it is coded in Python. In our language, NumPy is not used, something else is used. In Rust, the Rust is also another language. In Ruby, in Java, it is not NumPy, but some other thing that is being used, which is handling the data at a root level. Okay. But for Python, NumPy. Okay. Cool. All right. All right. Let's go for a quick break. And once we come back, we'll pick it up from here. Okay. 5, 10, some mix. Okay. Let's go for a 7-minute break between 5 and 10. Okay. Cool. Starting the break now. Hey everyone, are you back? Are you guys back? Should we proceed? Yes? All right. Okay, cool. So let me put away my tab and let me bring in my keyboard. We're going to look at some hands on. Okay, let's do this hands on. Well, trust me, even I'm a fan of dark mode, but this is much more convenient on a forum like this where everyone has to look at this. Okay, cool. Here, here, what we are going to look at is I'll tell that. Who is that? Mm, Shrikant, I think you asked me this question earlier also. So I will answer this towards the last, right? I hope till then you will be able to concentrate on what I'm teaching. I promise I will tell what I'm using towards the end. At least in that expectation, you will, attend the class. Yeah, cool. All right. So guys, here in NumPy, when you have to install NumPy, when you're doing this, I'm using a collab because it is much easier for me to share this with you guys. Okay. But if you are doing this in Jupyter, you might have to add this additional step, which is pip install NumPy. Okay. You have to do this package installation has to be done in Jupyter. Okay. Package installation has to be done in Jupyter. Okay. But since I'm using VS Code, also you will have to do. VS Code is nothing but a Jupyter kernel running on the background. Okay. Doesn't matter. If you're running this on your local, you will have to run this first line pip install numpy. Okay. But since we are on Colab and Google has already provided us some packages, it has installed and kept it already for us. We don't have to run this one line. All we have to do is import numpy as np. And in fact, all the people who are using this in your local, this is going to be your first line, and then you will also have to import this. This means install this to my computer. This means I want to use it here. Okay. Okay. So let me run this. Let me run this. And while it is running, let me to type in the next thing. So I want to show an example of Python list. And in Python list, we, you know, do it like 1, comma 2, comma 3, comma 4, comma 5. And let's try to print A. This is a Python list that you guys have already seen, right? Perfect. How do you know this is a list? There is a function called type. If you use this function or method type A, see, it tells you list. It tells you that it is a list, right? It tells you that it is a list. Okay, cool. Now, if I have to do this, if I have to do some operation here, let's say I want to take square of each element. How will I do it? You've already done your Python module. Can you write a program to give me the square of each element here in the Python list? I want you to return 1, 2 square will become 4, 3 square will be 9, 16, 25. I want 1, comma 4, comma 9, comma 16, comma 25. Can you write a program for it? Can you write a program for it? For I in A, I square. Yes, yes, that's absolutely like that. So let's do that. Let's do that. So this is I. And by the way, you are doing just multiplication. Either do the multiplication with I or do this raised to power. Okay, cool. Yeah, this is what I am doing. This is also I am doing what I am doing. This needs to be a list comprehension. See, we get this. We get this, right? Right? This is how it is done. This is how it is done. Okay. Okay. Let me add a few cells here. Now let's look at the NumPy array. NumPy array. Let's look at the NumPy array. So B is equals to, we are going to say np dot array. And as I told you earlier, also 1, 2, 3, 4, 5. How does the loop know what to execute? Huh? How does the loop know what to execute as in? Did not understand your question, Firoz. 1. It is not 1, it is I. Okay. So that is how we define a NumPy array. And how do you know that this is a NumPy array? Again, do type of B. See, NumPy dot ND array. So it is a general format. Even if it is a one-dimensional, two-dimensional, the type is going to become ND array. NumPy ND array. Okay. Okay. ND means n-dimensional. That is how it comes. It has been generalized. But you see the difference. For a Python list, it will tell you list. For a NumPy array, it is going to say NumPy.nd array. Okay. Now let's do the same operation here. Squaring each element of list. Can you also write a program to square each and every element here? I want to do the same thing here, meaning I want to get the same output here. NP stands for NumPy. See, this is an alias. So what we say is import NumPy as NP. So it will automatically understand wherever I am calling NP, it means import. Okay. It is NumPy. Okay. Now, squaring each element in NumPy array. You know how it is done? You know how it is done? Print B. That's it. No loop, nothing. No loop, nothing. What have I done? I have said B raised to power 2, B square. Remember, I told you that I will tell you one thing, element wise operation. Element wise operation. This is an example of that. You just said, just give me square of this array. So it is intelligent enough to say that this B is nothing but a NumPy array. So there are some elements inside it. When you're asking me to square it, I cannot square the entire array. What I can do is I can square each and every element inside the array. So it is automatically doing that. That is what I meant with element wise operations. This is an example of element wise operations. Okay. Okay. Clear? Are we good? Okay. Let's take an additional example of this. Another example of this. Similarly, if I have to adding 2 to each element in NumPy array, if I have to do that, I want to add 2 to each and every element. Good. Now you guys have got the idea. Easy, right? Easy peasy in NumPy. Imagine what you had to do in Python list. Okay. Perfect. Perfect. Cool. Now, let me also prove it to you. Time comparison between NumPy and lists. Let me show this to you as well. Okay. Because I told you that, okay, memory works in this manner. These things are there. Okay. Address is there. Postman example I gave you. Then homogeneous things are there. Okay. You have to do additional check on the data type of each element. And I also told you that, okay, NumPy is still faster. You agree with me. Okay. You agree with me. But, but what do you quantify it? How do you quantify it? Let's look at it. Okay. Let's look at this. So let's first do this for Python list. Let me say I want to create a range of, let's take a big number, uh, 1 lakh. Okay. 1 lakh. And let me print L so that you guys know what we are doing. So it is having a range between the number 0 to 1 lakh. Okay. It is having number 0, 1, 2, 3, 4, 5, 6, 7, all that till this point. That is what this range does. Okay. Now, let's do the same operation. Let's do the same operation. Let's calculate the time taken to square each element in Python list. Okay, let's do that. So to do that, to note down the time, you can use this magic function called time it. What it will do is it will give you the time. I will show the output also and I will explain along with it. But in a nutshell, if you keep this line in a cell, it is going to tell you the time it is taking to execute that cell. Okay. And what did we have to do to square each and every element in Python list for I in A? That is what we had to do, right? This is exactly what we did here. Instead of printing, I'm just executing it. Let's do this. See, it is taking time. Why? Because now I've given it 1 lakh numbers to square. Okay. In the list, I have 1 lakh numbers. So how much time it's taking? It's taking 611 nanoseconds. Plus minus, this is the error. Okay. That, it could take depending on your computer, the availability on the Colab, like how many people are using. This could be a plus minus error rate. But just focus on this part because error is fine. Okay. We are not worried about it as of now. it is taking 611 nanoseconds. That is also pretty fast, right? That is also very fast. That is also very fast. Let's do this in NumPy arrays. Let's do this in NumPy arrays. NumPy arrays. Now in NumPy arrays, let me call this as NP array, and this is going to be NP dot. Like we use range in this thing in list, we have a same function which is called a range, and you have to just pass that. Okay, I want 1 lakh, and I'm getting this. So instead of printing, let's take square of this, or let me first print it. That's how you do it. Okay, that's how you do it. Okay. Now let's calculate the time also for this. Let's now time this as well. Percentage time it. And how did we square? How did we square? Simply this. Use the array and just say that square it and give it to me. Right? Let's run this. How much time did it take? 66 nanoseconds. 66 microseconds. Right? 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 Isn't it fast? Right? Right? That's how things work. That's how things work. Okay. If you keep on changing, it will change. If you keep on changing, it will change. Okay. Okay. I'll tell you why you guys are getting confused, because of nanosecond. It is slower compared to microsecond. If you notice, we did a mistake. What we are doing is we are calculating the square of a, and a is having only 5 elements. In fact, we had to do a square of L. L is what is happening 1 to 1 lakh. Let's run this. Then we'll be able to compare, right? Look at this. 6.72 milliseconds, not micro, milliseconds. This is micro. This is 10 to the power minus 3. This is 10 to the power minus 6. Clear? At least 1,000 times faster. 1,000 or 100, because this is 6 and this is 61. Right? Are we clear? No more confusion between nano and micro and this, right? It was because we were using A here. We had to use this one. Okay. Okay. Yeah. For each and every percent, it will be kind of difference, but it will not be exactly what I am getting is 6. You might be getting something else. Okay. You might be getting something else, but the difference between these two should be the same, almost the same, depending on, how much compute you have, what all things you're using. Okay. So this is why, guys, this is why this is used. NumPy is used. You already see that this is at least in a simple operation like squaring, it is 100 times faster than Python list in a simple operation like this. When you have to do much more complex things like matrix multiplication, transpose, inverse, all those things, NumPy is going to outperform Python list by a long, long, long margin. If you add two more zeros here, if you add two more zeros here, this difference will become even more stark. Uh-oh, I need to run this also. Okay. Let's run this. Let's run this again. See, this is taking almost 1 second. This is taking almost 1 second. This is still taking 30 microseconds, 30 milliseconds. Sorry. Okay. It is almost 1000 times faster now. Almost. Or 900 times faster. Okay. So that's how things work, guys. That's how things work. NumPy is very, very fast. That is the reason why we use it. Okay. Cool. NumPy is under Python, of course. Yes. So for data science, we use NumPy a lot. Okay. Then let's look at the next topic that we discussed. What was that? We don't have much time, so I will just cover here. There are a few more things I want to talk on this topic, but we'll try to see whatever we can cover now. NumPys are homogeneous. NumPys are homogeneous. Okay. Whereas Python list, if I define Python list like a is equals to this, let me make this as a string. Let me make this as a floating point. If I do this, print the type of a. It is going to say list. It is going to say list. How do I define a NumPy array which is integer? How do I define a NumPy array which is integer? I will say b is equals to this, and I will print the type of b. It is going to tell me that a it is a NumPy array. But if I want to find what is the type of NumPy array, what is the type of the elements, I need to do b dot d type. B dot d type. With this NumPy array, give me the data type, not the type of b, but the data type. Look at this. Class is NumPy array. So this first line is telling you that this is a NumPy array. Then the second line is telling you that this is an integer array. This is an integer array. Okay. It is base 64. It is base 64. That is something related to the memory. You don't have to get into the concepts. There are different integer 32, integer 64. These things are there. All you need to focus is on the type. Okay. Don't worry. Cool. Let's look at a floating in also example. Okay, tell me one thing. Can I do this, guys? Can I do this? Will this work? Will this work? Let me show you if this will work or not. Same data type required, not homogeneous. Okay. But you know what? This will work. This will work. Let me comment this out first. It works. No error. No error. Why? Exactly. You got it. It converts everything to float. Let me show you. Look at this. Everything is converted to float. Let me print this also for you. Let me print B also. See, one dot, two dot, three dot, everything has been converted internally. It is it is intelligent that way. It is intelligent that way. That floating point is given to me. I cannot store everything as one. I need to make it homogeneous. Since floating point has a higher ranking compared to integer, it will convert everything to integer. It will convert everything to integer. Now you might be asking, what about the ranking? Can you tell us what is the rank? Which data type has the highest preference? Which data type is having the highest preference? Okay, let's solve this. That is what I wanted to discuss. I think we have enough time. Okay. Yes, D type is a method. D type is a method. Okay, let's discuss this. I'm not going to give you the priority order. You guys are going to tell me. Okay, but we are going to look at ample amount of examples so that it is clear for you guys that what is the ordering. Okay, let's use this as an example. Let's use string. So instead of making it floating point, if I make this as a string, will this work or not work? First, it will work. It will work. Why? Because everything will either be converted to integer or will be converted to string. Okay, that is how it will work. But will it convert to integer or string? We don't know that yet because we don't know the ranking or the priority or the preferences of the data types. So that is what you are going to tell me. Let's look at this example. I think, in my experience, I don't think, but I know that this will be converted to a string. This will be converted to a string. Now you might be thinking, Rishabh, this has only integer and string. What if we had a floating point also here? Will it convert to integer, float, or string? From this example, we already know that floating point is at a higher priority than integer. So the competition is between float and string. Either it is going to be float or string. Okay, let's run this. Everything is string. Everything is string. Okay, everything is converted to a string. Cool. Okay, okay, that is good. Now, trick question. There is another type, data type, right? What is that? What is that? Let me convert this to 4 and let me convert this to true. Boolean. What will happen now? String is not there. String is not there. What will happen? Float with Boolean. String is not there only. This true is a Boolean. Internally, if you print true, it will give you 1. How will it be integer? We have already seen that when you have a combination of integer and float, it is going to make it float. Let's run this. Everything is float. See, this true has been converted to one dot. One dot. Everything is converted to float. Yes, one dot means 10. Okay. Now with this understanding, can you tell me what is this going to be? Yeah, let me put false here. Just if you guys didn't know this already. Everything is converted to a string. Everything is converted to a string. Between integer and boolean, okay, वो भी कर लेते हैं. So let's make this true. Let's make this false. Let's make this true. Let's make this an integer. Right? This is what you're asking. This is what you're asking. What is your guess? What is your guess? Integer? Integer? You are right. It is an integer. So now, can you give me the priority order? Can you give me the priority order? Order of preference. Order of preference. Order of preference. Is this correct? Is this correct? Perfect. Perfect. See, I didn't teach you. You got to understand it on its own. In this way, now you will never forget. Otherwise, you might have been, very confused. Okay, kisko kya karna hai? It changes where. Okay. But now it should be clear. Okay. It should be clear. And even if you forget in the future, you know how to solve it. Okay. Even if you are stuck 5 years, 6 years down the line, you know how to solve it. It shouldn't be a problem now. Okay. Cool. All right. I think that is the content, guys, for today. Let me do one thing. Let me take some questions and let me, in the meanwhile, upload these notes also to your Google Drive so that you guys can confirm before you leave that if you can see it. Okay. Just give me a second. Just give me a second. This batch is weekday April 25, April 25, April 25. There you go. Okay. Can you check if you can see the notes on the drive? Can you confirm? Yeah. NumPy. And this collab is also there in Google Drive only. Whatever we did here is already updated in the Google Drive. Okay. Share the link. Don't have the link. I'll reshare it. Yes, Kiran, you're right. Okay. Cool. Okay. Let me take some questions here. Let me now get rid of the screen share. Guys, everything, are we clear? Type a CLR if we are clear. If you're clear, please type a CLR. Okay. In float conversion, where 4 change to 0. Why teaser? Why not 0.10? Because see, Sanil, what will happen is then you're changing the entire value also, right? It is just saying that I need to change, save one as float. That is why it is saying 1 point. 1 and 1 point, at least the magnitude wise is the same, right? Value is still the same. It's the data type that has changed. And NumPy is going to do that only. It is just changing your data type. It is not changing the value of it. Okay. That's the reason. When to use 1979? No, no, Ruchi. It is only in the beginning, just to make sure that you can hear me well, you can see the screen. That is the OTP of the class. For today, it was 1979. Tomorrow we don't have a class. Next Tuesday, we'll have a different OTP. So it's a that use only. Yeah. All OTPs, like in real world, will expire after 10 minutes. Okay. Cool. Perfect. Please explain the difference between .py and IPy notebook. Okay. So when you save a Jupyter notebook, you will see an extension like IPy notebook. What it will give is it will give you the ability to run it cell by cell, like how I was running. When you save a code as .py, what will happen is it will run in one flow. It will run in one flow, meaning you will not have the ability that, okay, run this cell, then this cell, then this cell. It will run in one go. The entire script will be executed. Yeah. Complex data type like, can you give an example, Sudhir? Is list still important in Python? Yes, it is. It is. That is why we studied it. Data science, all the numerical work, majority of the times you're going to use NumPy, but lists also kind of, you will use it somewhere or the other. When once you go uh, and look at few things in machine learning and hands-on, especially, you'll get it. Okay. Sir, every trainer, one question I asked, can you speak Hindi? हाँ बिल्कुल मैं तो हिंदी बोल सकता हूँ, but not everyone is comfortable, so I just chose English. But let me know if you want to, if all of you agree, 100 150 people who are there in the session now, if all of you agree in Hindi. Session is really good and effective. Thank you, Ruchi. Confirmation. What confirmation? Shubhadeep, I think if that is a continuation to some question, I don't see the other one. U21, what is this? Again, U means unistring. Internally, it is used as unistring. It means nothing but string. Okay. 21 is how it is saving internally. That is not for you. That is not for you. It is much more deeper in OS level things. Don't have to worry about it. Then why for false the output is not zero? For false, the output will be zero, Sanil. The false, the output will be zero. Look at the last string. I think you're getting confused because um, when we did the false example, we had put string, so it gave false in quotes. But in the next, when one of you gave an ask a question that what if we do integer and boolean, then over there, if you look at the last cell, let me see if I can share my screen without being cut off. I hope you can hear me. This one, look at this. False. Last one should be false, should be zero. Look at this. This is zero. Even this is zero. Session really good and effective. Thank you. Um, Confirmation. Okay, same output. Then I hope that is clear, Sanil. Okay, we are getting 0. Here we said that, we had a put string also. So everything was converted to string, and even this false was converted to string. Pranav, where is your question? Can you please retype? .py is Python file. Is notebook integrated with Python? Yes, that is true. Shubhadeep, in complex numbers, we don't have complex and imaginary numbers in data science. That is just a concept in mathematical sense, right? But if you're talking about vectors, yes, we do have vectors, and it will be saved in numpys. Okay, it will be saved as numpys, as matrices, matrix, ND arrays. They will also internally be integer, float, something like that only, right? Where is the feedback? I don't know. Sir, are you telling NumPy is mostly used in data science? Yes. Anything you have to do with related to numbers, you can still use list also. There is no harm. I did the same things in list also here, right? I did the squaring also. You can do addition also. It's just that NumPy usage is fast. Usage is fast. Okay. How much mathematical knowledge needed? हो जाएगा शुभदीप. Don't worry. Don't worry. I am there, no? We'll cover it in that manner only. Don't speak Hindi? Sure, Rajshekhar. We will not. That's why I chose not to speak Hindi. Okay. It was nice session. Thank you. I think there are students from abroad. Of course, that's why. So we are going to restrict ourselves to English. That's full and final. You will give us real world problem and solution using NumPy. I will try my best. Today I gave you an example of digit, right? Gave you an example of digit, how it is used. Okay, cool. NumPy class was interesting. Thank you so much. Have a blessed weekend. Same to you. Same to you. Rebello, I hope I'm pronouncing your name correctly. Thanks for explaining. No worries. Great time. Thank you so much. Teaching. Have a nice day. Okay. You know Telugu? No. I'm a Punjabi, so I know Punjabi. Do you know Kannada? I know a bit of Kannada. Yes, Varu. I would say 80% of 90% of Kannada I can understand, and I can speak 30-40%. Like in list, we can use indexing. Of course, Mansi. That's the next session about. That's the next session about. Okay. Cool. Pranav, I am trying my best to do that. Today we were able to follow that, and we are extending till 7 minutes additional. So just answering your questions. Cool. All right. Grace class. Perfect. Thank you. Earlier faculty only provided basic teaching. Everyone is good, Harish. Everyone is good, in my opinion. You have many questions. All right. Everyone else, you feel free to drop. Feel free to drop. I think Firoz had also earlier asked me to unmute him. So I'll just take his question, but I'm not covering anything new. So feel free to drop. The session is over. Okay. Thank you. Take care. Firoz, I have sent a request to
Thank you
unmute.
for unmuting me. I have several questions. First thing is when we have some scenario-based question, it's not possible to take that at the end of the session. So can you please do it so that it will be interactive, not just like we are watching the videos and like that?
What type of scenarios?
For example, I have some question in certain scenario. You are explaining something, and I got a confusion, and I have a question. This is not possible that every question I can convert it to text and it will be understood by you because of my whether my English or whatever scenario. I didn't got that.
Mm-hmm.
So my first question is when you wrote the loop,
Mm-hmm.
the body of this loop
Mm-hmm.
you didn't define it. And this is the first time I am seeing this such a syntax. So I need some more clarification about that.
This one, you're talking about this?
Exactly. This I wrote the question or the text, and I couldn't explain the things. Okay.
Okay. Okay. So you're asking two questions. First one is the request that explain the scenarios, and if you type in, probably I'll be able to explain. Or you want me to unmute then and there. See,
Yes.
unmuting, it will take a lot of time, like you will explain and everything. The flow of the class, interrupts. What happens is, to explain 1% or 2%, entire 150, 200 people will suffer. Okay. That's why I try to do it towards the end. Second, if you're able to convert it or type it in message, trust me, I really understand things. I have a lot of experience teaching and also training in my real life. So if you can even explain 30%, 40%, I'll be able to, get your question. That's the first thing. Second, now actually answering your question, that why this is, working, we have not defined the body. I hope you have covered the list comprehensions in your Python modules. This is the keyword, list comprehension.
No, this is the first time I am experiencing it in programming.
So,
I'm the .NET programmer, so this is the first thing I am
got it.
listening.
Got it. Okay. So this is basically the same syntax. If you look at this is a shorthand in Python. Let me go and write it here, explain it here. Okay. This is basically a shorthand. If I remove this, how do you read this is, if you look at this is exactly same as a for loop, right? This is exactly same as for loop,
Column.
right?
Okay.
Okay. Now, how do you read this? This is a shorthand for loop only. Okay. There are two things happening here. One is, you also need to understand how it is read. So always read the right hand side first. So
Okay.
you're going to say for I in A, then read the left hand side. Do this. This is the operation that is happening. That is the first thing, how to read it. Second is, you are enclosing it inside a list, right? The square brackets. So whatever result that you're getting, you are encapsulating it in a list rather than, taking it element wise, and then doing a, append. Let's say I'm defining a list here. Let's say A is some list. Okay. A is some list here. And I am saying A dot append this I, or whatever this we got. Let's say this is
Dot append.
square. Yeah. A dot append. Rather than doing all this, you are just doing it in a shorthand, saying that do it for each element and give me the result element by element and save it in a list. That is what we are doing here in these 4 lines. That can be done here in 1 line. That's how the syntax is.
Okay. It's included only one line is included there. Can we include one more line?
Where?
In this loop.
In this loop, yes, but everything is in 1 line. Like if you have if else condition,
yes,
you can again do if, condition A, then do something, then else do this.
Okay.
Condition, like this. It will work in 1 line only.
Okay. So I have to prefix or postfix.
Yes.
Statement.
Yes. This will come here. If this, basically whatever the condition is, do action 1, else do this. Something like that.
Okay.
Just read about list comprehensions, you'll get it.
Okay.
It's just a shorthand. It's not mandatory thing. You can still do the same thing with for loop here. It's exactly the same. Doesn't matter. It's just a choice of coding.
Okay, this is very great thing. It will
Perfect.
compact our code. And second question, my question was that when you print the 1,000 lines, 1,000 values,
Mm-hmm.
it printed dot 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 like that.
Yeah, this one is it?
Okay.
Yeah.
So what if I need it?
Then you have to go with the for loop. It is just compacting and saying that okay, you have values starting from 0, 1, 2, then dot 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 as in these values and till this.
So,
It is showing you first three and last three. Internally, it has those values. But if you want to access it, you can access it. Let's say I want to access um, some let me access something. We are going to cover this tomorrow, but if I want to access 6, I'm going to get this.
okay.
Yeah, like this.
It wrote np.int64. Okay.
Mm-hmm.
But I didn't ask for the data type. Why we got the
We
data type also?
exactly. We are going to look at this in the next session, so I don't want to confuse you now.
Okay. And
Okay.
second thing is time. It's percentage time it.
Mm-hmm. Mm-hmm.
Sometimes it's in microseconds, sometimes it's in nanoseconds. Can we make it all microseconds or nanoseconds?
Explore this. I think there are some parameters that you can use. You can explore this. You can modify it according to what you need.
Okay. And can you scroll a bit down, please?
Mm-hmm.
Okay, a little bit up. The first example.
Mm-hmm.
Okay. Here, if we will give a string of 2,
Mm-hmm.
this one, what will be the data type? It will be int64. Okay.
For
this above one.
Python list or integer?
List.
Array.
I'm talking about list. No.
List.
Okay, it's heterogeneous. Can you please little bit down? Where we have mentioned that it implicitly converts the data type. Okay.
Yes.
So can you be little bit down? Scroll a little bit down again. Okay, here it's 4. Okay. What was the data type? It was the Unicode string 32. Okay.
Yes.
Can you please little bit down? I don't remember where it was. But okay, here we can see here. Okay, false 4. Why it got explicitly it got converted? Is there any first thing? Is there any
Yes.
conversion?
For others, you can leave the session. I'm not covering anything new. Yeah, go ahead.
Okay. Is it explicitly converting anything? Do we have an explicit conversion in NumPy?
It is doing exactly what is doing here.
Yeah, it's
implicitly converting.
It's automatically, yes.
Yes.
It's automatically converting.
Yes.
Do we have an explicit conversion so that I can forcefully convert anything?
Yes, that is called as type int. If you want to convert something to integer, you can use this function np.asType. If you want to convert to integer, if you want to convert to this, all these things are there.
Okay.
Integer, string, float. That's a different function.
Okay.
Typecasting.
Yes, typecasting
is there.
So my request again is that we missed several questions. Several questions I forget. That
note it down. See, for you to be honest, for only one student, I cannot, hold the entire class of 200 folks. It's not fair for the others. But to be fair for you, I'm handling this towards the end.
Okay, as you wish.
Okay. No, it's not wish. That's how I've been running it, and that's the most efficient way of doing it.
There are several. There are several things that I asked several questions, and maybe they will be also benefited. It's not like the questions that I have some confusion, like I am not able to understand.
Mm-hmm.
These were just a little bit deeper questions, so that
Mm-hmm.
everybody should have updated with this knowledge.
But that is your assumption, right?
Yes, exactly. I can say.
So, so exactly. So, if people have their questions, they are also going to ask it. And we started with around 200 people in the session. Now there's only 30 people left. So, and they're also just here. I am 100% sure at least 50% of them are here that they might miss something. That's why they're staying here, not necessarily because they have the same doubts.
Yes, exactly.
Okay, good. All
Okay,
right.
thanks. I
Perfect. In
basically,
case of any doubts, even after the sessions, reach out to me. I'll be able to help. Okay.
thanks
No worries.
for your support. Thanks. Thank
Perfect.
you.
Perfect. Yeah. All right. Chalo. Bye bye. Take care.
Bye.